So a large majority of languages, almost 90%, have a voicing contrast in obstruents. And this contrast is implemented through two main mechanisms. One makes use of the feature voice, which contrasts pre-voiced stops and unaspirated voiceless stops. So languages that fall into this category are most of the Romance languages, Slavic languages, Hungarian, and Japanese and Dutch. The other mechanism uses the spread glottis feature, and this contrasts non-aspirated phonetically voiceless stops with long lag aspirated stops. So languages in this category are called aspirating languages, such as the Germanic languages, except for Dutch, Mandarin, and some Turkic languages. So similar to Dutch, who is an exception within the Germanic family when it comes to voicing, European Portuguese has been claimed to diverge from the other Romance languages. It is typically considered to have a voice contrast, but there have been both small acoustic studies and large-scale corpora studies that showed that there's a tendency for obstruents to not show consistent and robust voicing. So for example, there high rates of devoicing have been found for both stops and fricatives in European Portuguese. European Portuguese also has voicing profiles that are more similar to Germanic languages based on small acoustic studies. Another example is that decision tree-based classification separate Portuguese from Spanish, French, Italian, and Romanian. And finally, there's a study from 2016 which proposes an alternative analysis of the voicing system in European Portuguese, giving it a hybrid voicing system, which says that stops are specified for the voice feature and fricatives are specified for the spread glottis feature. So then the question we might ask is, does the implementation of the laryngeal contrast in European Portuguese show consistency with the Romance languages, or does it take a different path, more similar to languages that are both genetically and geographically different? There's a small study from 2015 that investigated this by comparing voicing profiles of both stops and fricatives in European Portuguese, German, and Italian. And based on 6 speaker per language, they found that voicing probability drops after 30% of the obstruent in European Portuguese and German, whereas in Italian it stays close to 1 throughout the obstruent. So then we can refine our research question to, are voicing profiles in European Portuguese stops more similar to German than to Italian? And this we want to test on large-scale data. So studies at LISN use speech technology and large corpora to investigate phonetic variation to better understand how it shapes phonological systems in synchrony and diachrony. And lenition and fortition phenomena, with a particular focus on voicing alternations in obstruents, are one of the main topics of interest. What we do is we take transcribed corpora and use pronunciation, language-specific pronunciation dictionaries to force align the data and detect voicing alternation, for example. So here we have an example of 2 instances of the word sabe in European Portuguese. Both have final vowel reduction. On the left, we have an example of the system which detected here B that is voiced. So sabe. And on the right, it's B that is detected as devoiced by the systems. I don't know if you heard that, but as you can see, there's a clear difference between the two. So to investigate our research question, we focus on a European Portuguese corpus of 114 hours of broadcast news, speech, and TV and from TV and radio shows. The data was acquired from the LDC, ELRA, and other international projects. We had manual transcription for the whole of the 114 hours of speech, And we forced aligned these transcriptions using a trained acoustic model and pronunciation dictionaries for Portuguese. The table shows the count of phonemically voiced stops that were found in the corpora. So to test whether European Portuguese voicing profiles are closer to German or to Italian, we focused and manipulated the acoustic models that were used to force align the system. So in addition to the original Portuguese acoustic model, we added two other acoustic models for B, D, G, one for German and, one for German and one for Italian. And then we did different combinations of acoustic models that were presented to the model. All acoustic models were trained on similar types of data and similar amounts of data using the same acoustic analysis and using the same type of models. So using these methodologies, we make the following predictions. So if we take previous results into account, if voicing in European Portuguese stops is more similar to German, we would expect the recognition system to choose the German model to a higher degree than the Italian one. If, however, voicing in European Portuguese behaves more like Italian, we would expect the opposite, and the Italian acoustic model would be preferred by the system. So we tested this in 3 different experiments where we did different combinations of acoustic models. The first experiment, we had all 3 acoustic models in parallel, and the system had to choose between one of the 3. Results show, as you would expect, that in the majority of cases, the Portuguese original model was used. However, in 28% of the cases, either the German or the Italian model, acoustic model, was chosen by the system for B, D, G. Of these 28% of cases, the German acoustic model was preferred only in the case of bilabials. So you have here the percentages and counts for each stop. The percentages aren't that different, but for this amount of data, everything is significant. Now we go to experiment 2, in which we took out the Portuguese model and only left the Italian and the German acoustic models. So the system now has to choose between either a German B or an Italian B. Results show, like the first experiment, that the Italian model is preferred for coronals and velars, and that German is preferred only in the case of bilabials. So this is a little bit different from what Pape and Jesus 2015 said. So it seems that the balance is in favor of Italian and not German. We have the count and percentages here. Now, in experiment 3, we changed the methodology slightly. Instead of using more than one language acoustic models together and letting the system choose between the different acoustic models, we ran one language at a time, but now we added enriched dictionaries with pronunciation variants. So that means for a word like cat, gata in Portuguese, you might have the possible pronunciations gata, kata, kada, and gada. So the system chose between one of these 4 pronunciations. And then we tested one language at a time. So based on Pape and Jesus 2015, if German and European Portuguese both have a drop in voicing probability starting 30%, and Italian has a voicing probability of 1 throughout the obstruent, our prediction would be that higher percentages of voiceless variants would be used when the Italian acoustic model is optional. So this is the case for bilabials and coronals, but not for bilabials and velars, sorry, but not for coronals. So the German model is only preferred in the case of coronals. So they detect more voiceless variants. This goes against our predictions and against the results of the first 2 experiments. So now the balance is in favor of German and not Italian. So you have the count and the percentages in the table. We can come back to them later. So as an interim conclusion, in the first 2 experiments, we show that European Portuguese voicing profiles of B de G are closer to Italian than to German. This seems to be dependent on place of articulation of the consonant, with the bilabials being the German being preferred only for the bilabials. Now, a method using pronunciation variant instead of letting the system choose its preferred acoustic model suggests the opposite, but there is always a distinction based on place of articulation in all 3 experiments. We did a final experiment, so we did the pronunciation variant experiments on fricatives this time to see what happened. So again, they had to choose between either a voiced or a voiceless variant while testing 1 language at a time. So just a reminder, so here again, we predicted that higher percentages of voiceless variants would be detected when Italian is the acoustic model of choice if we take Pape and Jesus results into account. And this is the case independent of place of articulation. So fricatives are closer to German, independent of place of articulation. So as you can see here, for the V, 90% of variants are considered voiceless by the Italian acoustic model. So independent of place of articulation, EP fricatives are more like German, and the pattern clearly diverges from the one found for stops. So this would be in support of a hybrid voicing system, so stops versus fricatives. So in conclusion, we found that European Portuguese stop voicing patterns are not more similar than to German than to Italian, only in the case of bilabials, and that fricatives voicing patterns are more similar to German independent of place of articulation. So these results support the proposal that there's a hybrid voicing system for European Portuguese obstruents and could be an indication of sound change in European Portuguese. So a shift from classic voicing systems known for Romance languages to a hybrid voicing system. And these results also support the use of automatic speech alignment systems to test phonetic predictions on large-scale corpora together with acoustic analysis, for examples. And to finish off, I'd like to present a few future avenues for research. So we would like to replicate this, all 4 experiments on German and Italian data to make a full circle. Of course, we're investigating positional effects, see which variants appear in which phonological contexts. There's a further need to investigate the stop fricative differences, and of course, acoustic data is an acoustic data analysis is needed to see what's actually happening. Thank you.